In the next hour, you are going to learn everything you need to know about Pandas, Python's most powerful data analysis library. We'll go from absolute basics to advanced techniques covering data frames, data cleaning, aggregation, and by the end, you'll be able to analyze real world data sets very confidently. I'll be coding everything live. You code along with me. But first, let me tell you why Pandas is actually used and why it's such a big deal. So, before we go into the code, let me answer three questions. What is Pandas? Why is it called Pandas? And why should you care? We'll answer these three questions. So first, let's start. What is Pandas? Pandas is a Python library for data manipulation and analysis. If you have a raw data, you can use Pandas to gain insights from that data. Think of it as like Excel on steroids or SQL in Python, but way more powerful and flexible. Pandas gives you the tools to make messy real world data and transform it into clean and analyzed insights. It sits right in the middle of your data pipeline. You load data from CSV files, databases, APIs, web sources, and then you can use Pandas to clean it, transform it, and prepare it for visualization or machine learning. Why do we call it as Pandas? Pandas name is actually short form for panel data, which is an econometrics term for multidimensional structured datasets. The creator who developed Pandas in 2008 while working at a hedge fund specifically designed it to handle financial time series data. He needed something that could handle tables of data, think rows and columns like spreadsheet, but with the power and the speed of Python. The name Pandas is just a coincidence from the animal panda, but it actually comes from the name panel data system. Now you might hear people debate about whether the S stands for system or whether it just makes it plural. But either way, it's about structured and tabular data. Now, why do you need to know about pandas? Where is pandas used in real world? Pandas is used in mostly data science and machine learning, where you can use it to clean the data. You can use it to perform feature engineering. You can use it to perform exploratory data analysis. You can use it to handle missing values, etc. For example, if you are trying to prepare a customer data for doing a recommendation system, you can use pandas in that way. It can also be used in business analytics, where you can use it for sales analysis and reporting, customer segmentation, financial analysis, KPI tracking, etc. So analyzing monthly sales across regions and etc. so on. So these are some big use cases in which pandas is used. In data science and machine learning, pandas is used because you can train any model. You need to clean your data, you need to handle missing values, you need to create new features. Pandas will be able to help you do all of this. About 80% of data scientists' time is spent on data preparation, and Pandas is a primary tool for that. And coming to business analytics, Pandas is very perfect for generalizing reports, analyzing trends, understanding customer behavior, tracking key metrics. So if you ever done analysis in Excel but wish you could get automated it or handle larger data sets, Pandas would be your answer. The bottom line is this: if you work with tabular data in Python, which means data is organized in rows and columns, Pandas is the standard tool. It is used by millions of data professionals worldwide, from Fortune 500 companies to startups to academic research. Learning pandas is one of the most impactful skills you can develop in Python ecosystem. So whether you're aspiring to be a data scientist, a business analyst, a data engineer, or someone who just need to work with data in Python, pandas is absolutely essential. By the end of this video, you'll be comfortable working with pandas at a professional level. So let's just get started. So here I have an empty Google Colab notebook. So let me start by importing pandas, and we can configure it with best practices so that you'll be able to use it right away. To import pandas, you can type import pandas as PD, and pandas is built on top of NumPy, so you can import NumPy as NP as well. First, we import pandas with alias PD. Everyone uses this convention, so you should just stick with it. And will also import NumPy as NP because pandas is built on top of NumPy and we'll need it for certain operations. Now, the next line is very important. We are enabling copy on write mode. To do that, you can do pd dot options dot mode dot copy on write is equals to true. Now, this is a new feature that will be default in Pandas version 3.0, but you should start using it new. What it does is prevent confusing bugs where modifying a view of data frame will accidentally modify the original. It makes Pandas behavior more predictable and safer. Now, the next two settings which we are going to try are just for our convenience. We can do pd.set option and display.max columns to none. and pd dot set option display dot display dot precision to 2. These display settings are just for our convenience. We are telling pandas to show all the columns when we print the data frames instead of just truncating them, and to round the floating values to just 2 decimal points for clearer output. Finally, let's just check our pandas version as well, which should be around greater than 2.0. pd dot version should be around greater than 2.0, which will have all the modern features we'll be using today. Now, Pandas has two core data structures you need to understand. So let me draw this out. One of them is called as series and one of them is called as data frame. Now, series is a one-dimensional array with labels. Series is a one-dimensional array with labels. Let us take an example. Let us say you have an array consisting of values 10, 20, 30, 40. Now, series is something which will have, and it is an extension of array which will have labels as well. Now, the labels can be anything. It might be numbers which you can give, or it might be some values which you can give. So, I think let's just give them different labels. This is 0, this is 1, this is 2, this is 3. We'll take one more example to get a clearer understanding. Let's say you had to mark students' data along with their marks. So a Panda series could be in the form of the student's name as the label and the student marks as the value. So it might be something like Joel having 100 marks, Jack having 50 marks, Lily having 20 marks, and finally Dan having 70 marks. This is called as a pandas series. It is an extension of an array consisting of labels as well. You can consider this as a singular column value as well. Now, the second part is called as a data frame. Now, this data frame is in the form of tabular form. It has several rows and several columns. You can think of it as an Excel spreadsheet or an SQL table. Just to revise, the series is a fundamental block of pandas. You can think of it like a single column of data with different labels. Data frame is a collection of rows and columns, or you can say it is a collection of series, because we have seen that each column in a data frame will represent a series. Now let's go check this out in code. Here, I'll show you how you can create a series. So let's take an variable called ages is equals to. You can create a series by using pd.series, and in here I can pass in a list, and I can pass in parameter called indices equals to, and give the values of the indices as well. Now, if you just print this series, this is not indices, this is index. If you print this series, you can see that these are the different labels and these are the different values. As you can see, I'm passing two things. First is a list, and second is an index parameter where I specify the custom labels for each value. Instead of using the default numeric index, if you remove this index parameter, you will get the default numeric index 0, 1, 2, 3. The beautiful thing about index is that it allows you to access data by meaningful labels instead of just giving numeric positions. So instead of saying give me the value at position 0, you can say give me the value for Alice. So this is what makes pandas so much more powerful than NumPy arrays. Now let us try to see how we can create a data frame. Let's say I have this dictionary, Python dictionary with me. In this dictionary, each key value will become a column name, and each of these values will become the values for that data for that column. So the key name will become our name column, and the values in there will become our values in the column. The key age will become the age column. The key city will become our city column. Now to create a data frame, all we can do is just type df is equals to pd dot data frame and then pass on this data. Now, if you print out this df, you'll be able to see it in a clean structural format. Now, the best way to understand a data frame is to think of it exactly like Excel spreadsheet or SQL table. You'll have rows which are identified by the index. You have columns as well, which are identified by the column names. This two-dimensional structure is what we'll be working with 95% of the time in data analysis. Now, here is the first common mistake that a lot of beginners make. They confuse what is row and what is column. So, whenever you do length of this data frame, the value which you'll get will be equal to the number of rows, not the number of columns. If you want to have the number of columns, all you need to do is do the len of df dot columns. This will show you the value of the number of columns instead of showing the value of the number of rows. Okay, so whenever you do df dot shape, that means the tuple which forms here 4 comma 4 means that it has 4 rows and 4 columns. Now keep this in mind because we'll be talking about the axis parameters soon, and understanding this rows versus columns is very crucial for that. Now throughout this video I'll take an example of different data sets, but first we'll try to load a data set and try to work our way there. So I'll load the Titanic data set. Here we go. Now, once you do this, you'll immediately have the Titanic dataset in your df variable. So the first thing you always should do with any dataset is to inspect it. So I'll show you 5 methods, which are your first line of defense against bad data. What you can do is you can type df.head in here. Okay, the head method will show you the first 5 rows by default. It will give you like a quick peek of what your data looks like, what columns you have, what values you have in each column, in general structure. So if you want more data than just 5, you can pass in any number, let's say 10 over here, and then you can see 10 different values. This always is my first step whenever I'm trying to look at a new data set. The next thing which you can know is if you type df.info, this method is actually very valuable. It tells you several things. First, it will show you how many entries you have. And in this case, 891 rows you have. And it lists every column with its data type. As you can see, it lists survived, which is in 64. It says gender with object. It says embarked with object. Fair with float. The word object means it is typically mixed data types. The next thing which this shows, and which is super important, is that it will tell you the number of non-null counts for each column. So if you take a look at age here, you can see that it has 714 non-null values. It means we are missing age data for 177 passengers. This immediately will tell you where you are having missing data problems. And finally, it will show you the memory usage of this data set as well. Now, the df.describe method, the df.describe method will give you a statistical summary, but only for the numeric columns. You get count, you get mean, you get standard deviation, you get minimum 25 percentile, 50 percentile, 75 percentile, and max values as well. 25 percentile is also called as Q1. Median is the 50th percentile. 75 percentile is also called as Q3, and the maximum. This is perfect for spotting outliers or understanding the distribution of your numeric data. For example, I can see that the average age of people who boarded the Titanic is around 28, 29 to 29.7, which is 30. And you can see that the minimum age of the person who boarded the Titanic is 0.42 and the maximum is 80, which might be worth investigating. Now, df.shape is pretty straightforward. It will give you the count of number of rows and columns in the dataset. In our dataset, we have 891 rows and 15 columns. And the df.columns will give you the index object of all the columns in the data frame, and you can do dot to list in order to convert this into a Python list. Now these 5 methods, head, info, describe, shape, and columns, which we have seen, should be muscle memory. Run them every single time you learn and whenever you explore a new data set. Now before we go further, we must understand the axis parameter. This will confuse everyone at first, but once you get it, everything will click. So as you can see, I have a two-dimensional data given here. And whenever I say axis is equals to 0, we perform operations on each column. We perform operations on each column. Whenever we specify any operation and say that axis is 0, we perform operations on each column, and the result we'll get will be going down row wise, and you will be getting the results here. But whenever I specify axis is equals to 1, we'll be operating on each row and we'll go across columns. So that means the different values you will get when you say about axis is equals to 1, the operations are applied in this direction over here. And that means every single value which you get will be transformed over here like this. So let's take an example for this. If we apply the sum operation, with axis is equals to 0, the answer we would get would be sum operation being applied for every column over here. That means it would be 1 plus 2 plus 3, which would be 6, 4 plus 5 plus 6, which would be 15, and 7 plus 8 plus 9, which would be 24. So whenever you do sum with axis is equals to 0, you will get the answer as 6, 15, and 24. Whenever you do sum with axis is equals to 1, that means you are performing operations on each row. You are performing operations on each row. So that is why the sum of each row would become 12 in this case, 15 in this case, and 18 in this case. So with axis is equals to 1, we would get it as 12, 15, and 18. So whenever the next time you get confused with axis, you can remember this. I know this is backwards from what you might expect, but this is just how pandas work. Once you internalize this, every operation with axis parameter will make sense. And most operations will default to axis is equals to 0. Let's take a look at this with the code. Now here you can see I have created the sample data frame over here. If I print this out, you can see this is the data frame which I'm trying to get, the same one which I've shown on the whiteboard. Now let's try to sum this data frame. So to sum, you can just type demo dot sum, and this would return the sum of all the values. And since I said that the default value would be across axis is equals to 0, we are getting the values for A as 6, for B as 15, and C as 24, just like we've seen here. So A as 6 is 1 plus 2 plus 3, which is 6, 4 plus 5 plus 6, which is 15, 7 plus 8 plus 9, which is 24. Now if you specify axis is equals to 1, then you would get the values across different rows. So the zeroth row is 1 plus 4 plus 7, which is 12, 2 plus 5 plus 8, which is 15, and 3 plus 6 plus 9, which is 18. Just like sum, you can do various things across different axes. You can, let us say, do mean across different axes. So across axis is equals to 0, the mean is 2, 5, and 8. And the across axis is equals to 1, the mean is 4, 5, and 6. Now, there's different ways in which you can drop values from a data frame. So in this data frame, let us say I want to drop the value of B. I want to remove the column of B. So what I can do is I can just do demo.drop, and I can specify the name of the column B. So when you want to drop a column, you have to use the axis 1 because you're trying to operate on the columnar axis. But when you want to drop a row, you have to use axis is equals to 0. This will come up constantly, so you have to understand it now itself. So here if I specify axis is equals to 1, I would be dropping the B column right here. Now, if I were to give an index between 0 and 2 and specify axis is equals to 0, I would drop that specific row. In this case, in the case of drop, you're specifying axis is equals to 1 means go through the columns like this and then drop whatever I ask you to drop. And in case of drop in rows, go through the rows like this in 0 axis and then drop whatever row I ask you to do. Let's talk about selecting data. This is where most errors happen, and we'll do this carefully. So let's say you want to select a certain column. We have the data frame as pandas, our Titanic data frame over here. Now, if you want to select the age column from this data frame, you can just use the square brackets and type in the name of the column, and you will be able to select that. The type of this df of age is a pandas series. So whenever you select a single column using the bracket notation, you'll get back a series. Now this is one column of data with the same index as the original data frame over here. This is the same index as the original data frame. This is fine for quick access, but there is a better way which I'll show you in a moment. Now, in case you want to select multiple columns, you can use double square brackets and specify the names of the columns you want to specify. So if I use a singular square bracket and put another square bracket consisting of all the different columns I want to access, you can see I got all that specific values. If I name the subset and then check the type of this subset, you can see that we got as a data frame. The most common mistake people would do here is forget the second pair of square brackets. If you write df of just this without the second square brackets, Python will throw an error because it thinks you're trying to pass multiple arguments in the bracket operator. So it is important you specify two brackets. Now here is a best practice which people use. You can use the accessor lock. Now what can we do with lock is you can pass in two parameters separated by a comma. On the left side of this comma, you will specify the rows you want, and on the right side of this comma, you'll specify the columns you want. You can specify this just like you would slice your indices, just like you would slice your lists or slice your numpy arrays in Python. So if I want all the rows, and I can specify the name of the columns I want, which is, let's say I'll take the same thing which is over here. You can see I'll get the same output. Now this is more explicit and it looks more clear on what you're trying to do, and it prevents certain edge cases and weird behaviors that can happen with the previous bracket notation. So you should get into habit of using lock for all of your selection processes. So if I were to select this value of 22, which lies at the 0th index and and at the column of age, I can use lock operator in such a way that I can do df.lock of 0th row and the age column. That will give me the value 22. You should remember that lock here uses labels and not indices or not positions. Although in this case, our position index happens to be numeric starting with 0. You can also slice with lock if you want the first three rows of the data frame and only the name and age. You can do that by doing df.lock and passing 0 colon 4, and you can specify the columns you want, and this would, okay, name doesn't exist, let's say the gender. So you can see the different specified values of the different columns from 0 to 4 and who and age. Now one thing which you can notice here is it is different from normal Python slicing, which will exclude the end, but pandas lock includes both the endpoints when using slicing, so you should remember that. Now here's where lock becomes very useful. You can pass Boolean indexing instead of specifying the rows and columns explicitly. I'll pass in a condition. So let's see how that works. So if I say df of age is greater than 18, the answer I would get is a Python series consisting of all the true and false values. If that value is greater than 18 or not. So I can use this same indexing in df.log to specify the rows I want and all the columns so that I'll get only certain filtered values out of it. Or if I just want the certain columns which I want, I can just specify them over here and then be able to see that everything which I've seen over here is greater than 18. So you can specify these boolean values. The condition df age greater than 18 will create a boolean series of containing true and falses, and the lock will use that boolean series to filter out the rows. So we can get the passengers whose age is above 18. This is one of the most common operations you will do in data analysis. Now, if you don't know the labels or if you don't know the name of the columns, but you still want to access them through indices, there is another method called df.ilog. It is the same as log, but it is indexed. Now here you can pass in the indices and of the different value of the different rows and different columns, and you will be able to get the answers. But as you can see, in iloc, the last parameter is always excluded. With iloc, you can use this syntax as well to access the specified values using indices. Now, Boolean indexing is somewhere where Pandas truly shines. So let me show you how powerful this is. So let me take a data frame and let me take the column survived. Here you can see whether the person has survived the Titanic or not. So if I specify this equals to 1, I'll be able to get a Pandas series out which contains the values true and false. True is somewhere where the person has survived and false is somewhere where the person hasn't survived. Now, if I was to able to apply this onto a data frame, I'll get the certain rows and columns where the passenger has survived. I'll get the number of rows where the passenger has survived. So if you check the number of rows here, 342 out of how many ever we had in the data set, the people have survived. Now, in this expression itself, you can write using many other Boolean operators as well. Let's say I want to find the person who has survived and the persons who are greater than the age of 18. So I can just write df of age greater than 18 and specify a singular and operator over here and enclose these both conditions in brackets, in rounded brackets. And if I were to run this code, you will see I'll get the columns of everyone who has survived and the people whose age is greater than 18. So in this way, you can chain multiple Boolean operations in here as well. So in this way, you can chain multiple operations as well and be able to do with it. Now, a critical mistake which people do here is that you cannot use Python's AND or Python's OR operators on here. That will throw you an error. You'll have to use your bitwise operators. That is the ampersand, the pipe operator for OR, and the tilde operator for NOT. So in this case, you'll be able to filter out columns like this. Also, the parenthesis across each condition should be required. Without them, you'll get an error because of operator precedence. Now, there is a better way in which you can do this. You can use df.query. Now, in here, you can pass in a string with the values in this way. And now you'll be able to immediately see that by just writing the name of the column, the specified operator and the value according to the Python and or not, you will be able to write a string expression, not the actual Python code, and pass on this query and create appropriate Boolean logic. This is especially very nice if you want to have very complex conditions. Let us say you have two variables, min age, which is 18, and survivors only, which is 1. Now, if you want to use these variables inside a query, you can prefix them with an @ symbol. Let's see how that works. If you do df.query and say age is greater than @min age and survive is equals to @survivors only, then if I run this, I'll be able to get the values out. When you use this operator over here, it will tell Pandas to look at that variable in your namespace rather than treating it as a column name. Now you can check if the series values exist in a list by just doing df of, let's say we'll take the town, embark town, and if we use the method dot is in and pass in a list, let's say Southampton or Cherbourg, and if we run this, you'll be able to see that you'll be able to specify this value saying, hey, if the value of the embarked town in any column lies in this list, which is in this case Southampton and Cherbourg, if it lies in this, it will return true. If it doesn't lie in this, it will return false. Now, as usual with everything, you can use this as a Boolean mask in order to extract the certain rows as well. One more way of filtering is you can do the value of, let's say you have the series df.age, and you can just say dot between, and you can specify a range 20 and 40. Now it will check for all the people who are between ages 20 and 40, and it will include both of these 20 and 40. So wherever the value is between 20 and 40, it will use true, otherwise it will use false. Again, as usual, you can use this as a Boolean mask. Here is a quick challenge for you. You need to filter the Titanic dataset for the female passengers who are under 30 years old and who were in first class. So pause the video, try it for yourself, and then unpause to see the solution. Were you able to solve it? Let's try to solve it together. So we'll use first Boolean indexing, and then we'll also use query as well to solve the same problem in two ways. So our query was, we have to see if we have a date. We have to find the female passengers who are under 30 years old and who were in first class. So I'll first filter my values as df of gender is equals to female. Okay, I'll take this as a condition, the first condition. The next condition which I have to see is they have to be under 30 years old. So their age value should be less than 30. And the last one is who were in first class. So their class value should be equals to 1. df of p class will be equals to 1. Now I can just chain them using the AND operator, and I will be able to get the series. Now I can use this to I can use this to filter out the number of rows over here. So these are the number of rows in which the female passengers were under 30 years old and who were in first class. Now let's do the same thing using query parameters. So I will take the namespace method. I usually like to write them in variable names. So I'll take gender is equals to female and min age is equals to 30, and so this is max age which is 30, and class is equals to, the class is a keyword, uh, board class, let's say board class equals to 1. Now I can just do df dot query and I can say the value of gender is equals to gender, and the value of age is equals to max age, and the value of class is equals to board class. Now if I run this, I'll be able to get the values. The value of age is less than max age, it's not equals to, and I'll be able to get the same value. Now in this data frame which you were given, if you were to require to sort the values based on age, you can use a very convenient function called df.sort values, and then you can pass in the parameter of the column which you want to sort it along with. And if you do that, you'll be able to see that your values in the age column have been sorted in ascending order, and the null values will be going towards the end. Now you should remember that this one will sort them and return a new data frame. So it doesn't modify the original data frame unless and until you pass in a parameter called inplace is equals to true. And now if you do this, it will remodify the original data set. In this case, I'll not do that, so that we can continue using this data frame. But if you want this to sort in descending order, you can just pass in another parameter called ascending is equals to and set it to false. Now it will sort it in descending order, starting with the person who is 80 years old, and then go all the way, and the nan values will be stored at the end. Now you can also sort by using multiple parameters. So if I use df.sort values and pass in two parameters, let's say passenger class and then age, then it will first sort by the passenger class value. And whenever two rows passenger class value is the same, the immediate next thing it will do is sort by the age. So as you can see, for all passenger class ones, it has sorted with the age. For all passenger class twos, it will sort with the age, and so on. Now, if you can also specify whether you can sort this ascending or descending by using ascending is equals to and specifying whether the value at this index should be sorted in ascending or not. So if I want to sort this in ascending and sort the other one in descending, I can just pass in true comma false. And as you can see, the passenger classes have been sorted in ascending and the age has been sorted in descending order. And by default, the nan values are always escorted to the end. Whenever you want to get the top n values or the smallest n values of a data frame, instead of just sorting this, what you can do is you can use df.n largest, and you can specify the number, and you can specify the column on base in which you want the one to happen. So if you specify this, you'll be able to see the top 5 columns who have the maximum value of age. The same way you can use n smallest as well to get the top 5 columns which have very small age. Now here you can also specify multiple columns to deal with. You can specify multiple columns in order to deal with the proper sorting as well. Now real world data is always messy. Missing data is one issue which you'll face in any data analysis project. So isna method, df.isna isna method will return you a data frame of boolean values, prove if there is a missing value, and false if there is no missing value. When you call the dot sum on that, you will be able to see that it counts the true values because Python treats true as 1 and false as 0. So it will give you the count of missing values in each column. Now I can see that age has 177 missing values, embarked has 2 missing values, the tech value has 688 missing values. Now instead of taking the sum, you can take the mean and multiply it by 100 in order to get the percentage of missing values. So in age, 19% of the data is missing. In text, 77% of the data is missing. Overall, if you want to see the number of missing columns, number of missing uh, data cells, you can do df.isna.sum. This will show you the total number of missing data in your data frame. Now you can convert this into percentage by just dividing this by df.shape of 0 into df dot shape of 1, and it is around 6.5%. So if I just multiply this by 100, you can see that it is around 6.5%. You can use a method df.drop now. Now, what this will do is by default, it will drop any row that has at least one missing value in any column. So see how we went from 800 kind of rows to only 182 rows. Now we lost most of our data because the deck column, whatever we have over here, the deck column, whatever we have over here, has around 688 missing values. So we dropped many of our columns. So this is usually too aggressive, but that is one way of doing it. Now in Dropna, you can specify what column you can prioritize. So if I give a parameter called subset equals to, and let's say age, now I'll only drop the rows which has a missing value in the age column. So now we have 714 rows. One more thing which you can do is instead of dropping the rows which have missing values, you can drop entire columns which have missing values. So in this case, if I do df dot drop now and provide access is equals to 1, you will drop all the columns which have missing values. So in this case, you can see age is not there and tech is also not there. Now, sometimes you might agree that dropping the data is losing too much information. But instead, you can fill these missing values. The simplest way is to fill with a constant. So here I'm going to try to fill the missing deck values with a string named unknown so that we'll have no missing values. In order to do that, you can select a column df of deck dot fill now, and then whatever values you have, we'll call it unknown. Now if you see this, okay, now this is failing because df of deck is considered as a categorical variable, and now whenever you try to add a new value into the categorical variable, it will try to say that you cannot add a new category called unknown into the ones which are already defined. So in order to add them, you have to set the categories first. So in order to do that, you can use this one right here, df of deck dot cat dot add categories, and name it unknown. After you add that category, what you can do is just run this command. We can specify df dot deck equals to, and after you do that, once you run this, you will be able to see that every missing value which you have is being filled with the value unknown. You can do the same thing with numeric values also. So let's say I want to replace the missing values in age with its mean. So what I can do is I can do df.fill now with df of age dot fill now, my bad, df of age dot fill now with df of age dot mean. Now this will remove all the missing values in the age column, and then you will be able to have the particularly filled age column. So if I do dot is null dot sum on this, you'll be able to see that I have no missing values. So for numeric columns, it is a common strategy to fill it with the mean or median. Here I'm calculating mean for all the passengers. It is reasonable strategy because it doesn't change the overall average. But it does, what it does do it is it does reduce the variance. So whether it is appropriate or not, it will depend on your data and your analysis. Median is also often better because it is not affected by any outliers in the data. If you have extremely high or extremely low values, then the mean gets pulled in that direction, but median always remains stable. Now, another way in which you can do is you can use the method interpolate. So if you do interpolate and then specify a method in here, let's say the method is linear, and now if you run this, you'll be able to see that interpolation will estimate the missing value based on its surrounding values. So linear interpolation will draw like a straight line between the previous valid value and the next valid value. And then it will be filling out your missing values. Now this is slightly more sophisticated than just filling it with mean or median because it takes into account the local pattern in the data. But if we were able to see the isnull dot sum of this, you'll be able to see that I filled all my missing values. Now, every column in the data frame will have a certain data type. You can take a look at that by using df.dtypes. Now, you can see each column and their certain data type. Now, object is like a catch-all type that will basically mean it can be either string or it can be mixed types or anything. So, understanding data types matters because they affect memory usage and what operations they can perform. And often you can use smaller data types to save the memory. Passenger class here only has the values 1, 2, and 3. So, here instead of using the passenger class as int64, I'll try making this some kind of int8 so that I can preserve my memory. In the same way, survived also has only values 0 and 1. So instead of using int64, I can convert them into either a boolean so that I'll be able to do them properly. So that I'll be able to represent them properly. So if I were to do that, I can do df.p df of p class. I'll be making them in such a way that df of p class dot as type, and here in string I'll be able to specify whatever I wanted to convert it to. So now if I do df dot now if I do df dot d types, you can see that my passenger class has been converted to int 8. So I'll convert the survived class into boolean as well. So df of survive dot as type, and in here I'll specify bool, and if I just allocate this back to the arrays to the series itself, and now if I see df dot d types, you will be able to see that the survived value is bool. Now the simplest way in which you can add a column in a data frame is just direct assignment. So if I were to add a column df of age squared, I can just do df of age and power this by 2. And now if I do df dot columns, you can see that I have the value age squared here as well. Now the assign method is slightly better than creating multiple columns to create multiple columns at once, especially like in a chain. So what you can do is let's create a new data frame. Df assigned is equals to df dot assign, and in here you can pass in a series of lambda values. So let's say I'll create age squared is equals to lambda x of age whole square, and I'll say family size is equals to lambda x of SIBSP plus x of parent children plus 1. Now if I were to run this and check the columns, you will be able to see I have the values age squared and family size in here. So the assign method is better for creating multiple columns. You pass in the keyword arguments where the name of the column will be the left hand side, and the corresponding function you'll pass them as a lambda parameter on the right hand side. Here lambda x means the data frame itself, and so lambda x colon x bracket age here means that you're trying to do the df of age whole square. So in this way, you can assign multiple columns in one call, and it works nicely with a lot of calls as well. Now, for conditional logic, np.where is very useful. So if I were to create a column of adult, and I were to specify np.where df of age is greater than or equals to 18, then I will say that he is an adult, or which is true, or I'll say that he is not an adult, which is false. So if I were to do this and then specify and take a look at df, you'll see there's a new column called adult, and wherever the value is greater than 18, greater than or equals to 18, you can say that they are an adult. To drop multiple columns from a data set, what you can do is you can do the df.drop command, and in this specify a parameter columns is equals to a list, and you can pass in the number of whatever columns you want to drop. So if I were to drop the gender, if I were to drop the age, and let's drop another one, who, you will be able to see that I have you can see that I have dropped those values, and I will be able to show them here. One thing which you need to remember is this is not in place. This will return a new data frame which you should store it somewhere else, or you can pass in a parameter called in place is equals to true in order to make sure that it modifies the original data frame. If you want to find if there's any duplicated rows in the data frame, you can do df.duplicated, And this will see if whether each row is a duplicated value or not. And if you do dot sum, you will be able to find out the number of duplicated values. So in this case, I have 107 duplicated values in my data frame. Now you can use df.drop duplicates, and this drop duplicates. Now this will return a new data frame which has no duplicated values. Let's say non-do. I'll call this as non-do. And if I were to run this thing for non-do instead of df, I'll be able to see that I have no duplicated values. Now let's take a look at aggregation and group by. So every numeric column has aggregation methods like mean, median, max, min, and standard deviation. And these will return a single number summarizing the entire column. That means mean will give you the average, median will give you the middle value, max and min will give you maximum and minimum values. STD will give the standard deviation, which will measure the spread. So these are the basic descriptive statistics. I'll just show you them right here with for properly formatted code. You can see df of age dot mean will give you the mean, dot median will give you the median, dot max will give you the max value, min will give you the minimum value, and dot std will give you the standard deviation. Now you can also use dot var to get the variance as well, but you can use that as something else. Now, if you were to apply multiple aggregations at once, you can use the function dot agg and specify all the different aggregation functions which you want to apply, and you will get a clean, neat Pandas series with the results. Now, this is more efficient than calling each method separately, and it is especially useful for very large data sets. Now, dot count will give you the count of non-null values in the data set, and dot n unique in here will give you the number of unique values in the dataset. Now, value counts is one of the most powerful methods in categorical data. It will count how many times each unique value appears so that you can immediately tell about the distribution. So, for survival, let's see the value counts. If you do survive dot value counts, this will show you that there's only two values, true and false, which has the values 549 and 342. And if you were to see this in percentages, you can pass a parameter called normalize is equals to true. This will give it to you in percentages. If I multiply this by 100, you will be able to see that it is 61.62 and 38.38. Now let's talk about group by. Group by is the most powerful operation in Pandas. I'll show you visually what happens under the hood. So group by is basically given as a split, apply, and combined pattern. So whatever condition you give, the data frame is split according to different conditions and grouped by those values. And then a certain thing is applied on those values, and then finally you'll combine them in order to merge those results back together. So we'll take an example. Let's say you want to group by the passenger class. Okay. So in this case, we'll get a group by object, pandas group by object. And for each age in each passenger class, if you want to find the mean of them, you'll be easily be able to do that. So passenger class 1 has the mean age as 38. Passenger class 2 has a mean age of 29. Passenger class 3 has a mean age of 25. Now, this one will create a group by object. This will not compute anything yet. It just marks that we want to group the whole data set by using passenger class. Then we will select the age column from this group by object. And then finally we'll call the dot mean method on that. Now what pandas does is it will split the data into three groups based on passenger class values. One group for the first class, one group for the second class, and one group for the third class. So yeah, so the first passenger class is given as 38.23. The second passenger class is given as 29.88, and the third passenger class is given as 25.1. Now you can group by multiple columns also. So if you do df.group by, let's say I want to group by both the passenger class and the gender. In this case, let's see the mean of the people who survived. Okay, so as you can see over here, we first have six groups. First class is male, first class male, first class female, second class female, second class male, third class female, third class male. Now for each group we'll calculate the mean survival rate. So as you can see, the first class females had the most survival rate, and the least survival rate is the third class males. Now, instead of doing it like this, you will be able to apply the .agg function like we've seen before in this way, so that you'll get a clearer understanding of the descriptives of the stat of the class. So you can just apply .agg after you specify based on what column you are trying to apply the aggregates on, and there you'll get the value. So in this case, we are grouping by the passenger class, and for the age column, we are trying to find the mean, median, count, and standard deviation. Now let's take on the small exercise. You were given to calculate the average fare and survival rate for each embarkation point. So pause this video, try it out, and unpause it to see the solution. Okay, now that you have the chance to try this out for yourself, let's try to do it on our data. So I'll just group by the embark town. This will return a pandas data frame object. And here I'll apply the aggregate function so that I'll calculate the average fare and the average survival rate as well. So here I'll pass in through the fare value, and I'll apply mean on that. Now here you will be able to see that for the fare value, the average mean is this one. Now if you were to do for survival rate, you can just do that for survival rate. Okay, it's called survived, not survival rate. And as you can see, this is the average survival rate. Now you can do the same thing in this way as well. You can use the .agg function and give a key value pair in such a way that you will describe the name of the column in which you want to apply the aggregate on, and the value which you want to apply the aggregate. And in this case, name doesn't exist. And if you do this, you'll be able to see for embarked on the average fare and the survival rate. All right, so that's Pandas in one shot. We've covered data frames, we've covered series, covered selecting with lock and dialog, we've covered filtering Boolean indexing, handling missing data, data cleaning, transformation, and group by aggregations. So now you have everything you need. Practice with real data sets. That is how you'll truly learn. And for any other advanced methods, you can just refer to the Pandas documentation. That will help you get started as well. If this helped you, you can smash that like button, subscribe for more data science and machine learning kind of content, and drop a comment telling me what you want to see next. Now go build something amazing with Pandas. I'll see you all in another one.